What's going on YouTube? My name's Elliot from The Techie, and in today's video, I'm going to walk you through how to configure your devices using Claude Code. So let me show you where we're headed first, and then we'll get there together. So I just want to show you real quick. I'm going to ask Claude, show me the OSPF neighbors on R1. Now again, this is all natural language. We're not going to log into these routers to do anything, to touch the CLI. I'm going to do everything from Claude Code, okay? Now you see this here? This is structured data back from the device. This is not some raw CLI output, but actual parse data that the AI can now use. So let me show you how we built this, all right? So I'm going to open up a new tab here, and here's the power. I'm going to open up a new Claude window as well. And to get rid of that config, all I'm going to say is remove the OSPF configs from R1 and R2 so that we can start with a fresh slate, okay? Now, while that's working, let's talk about the problem. You know, the problem with our previous lab and our previous video is that all the information that we get was raw CLI data because all we were running were show commands, okay? So the problem, like I said, the problem with that is that the AI has to, use regex to parse that. And that can be problematic. It can be error prone and it's just more difficult to work with. So what we're going to do is we want to use structured data, Python dictionaries that the AI can use and can actually work with reliably. So the solution that we're going to use and implement to do this is pyATS. Now, pyATS was originally Cisco's test automation framework, which they've since open sourced. It has over 2,800 parsers available, and it allows us to convert that CLI output into structured data. So we're going to add this to our MCP server so that Claude can also use it as a tool. So the way it's going to work is we're going to ask Claude a question, then Claude is going to ask that question to our, you're going to use our MCP server to use the right tools to connect to our devices and to return that structured data via pyATS so that Claude can now reason with that data accurately. The way that we're going to do this is we're going to use a framework called TDD. If you're not familiar, it stands for test-driven deployment. Now, what this allows us to do is it allows us to capture the state of our network before we make any changes to it so that we have a baseline. And we'll then, once we have our baseline, then you'll be able to go ahead and make the change. And then after the change has been made, you'll verify that the change worked and has been implemented successfully. So let's see here if we've removed everything. Give me just a second to move these around. Claude's still working to remove our configs here, so give it just a second. And then we'll go ahead and configure everything. And I'll just let you kind of watch. As we see here, it's been removed from both routers. Now Claude's going to verify. Okay, so we're done. So as we can see, let's go ahead and set up OSPF on our devices. And the first thing that we need to do, however, is capture our baseline. So we need to do the test. And the way that I'm going to do that is I'm going to ask Claude to show me the current OSPF neighbors for R1, okay? Now remember in the last video, we gave Claude the ability to run show commands, which it is doing here. So it's gonna call R1 and run the show IP OSPF neighbor command, and the output is empty as expected. So R1 has no OSPF neighbors. And again, Claude tells us this is expected since we just removed OSPF from both routers. So that we now have our baseline. No OSPF running, no routing running between the two routers. So we're good on that point. Now we can go and config the devices. So the next thing that I want to do, like I said, I'm going to ask Claude to, let's say, configure OSPF process 1 on R1 and R2 using Is it gig? Yes, gigabit Ethernet 1. Let's say use 10.0.12 because we're going to use router 1 and 2.0/24 as the link network with R1 as, let's see, R1 as .1 and R2 as .2. Okay. And let's say put everything in area 0. Okay. So we've got our OSPF process. We're going to be at process 1. We're going to use gigabit Ethernet 1 for R2 and R1 and R2. That's our transit link. And then we're going to use the 10.0.12.0/24 link, our network, as our link network for R1 and R2, with R1 is .1 and R2 is .2. Okay. A little redundant, I know, but I just wanted to make sure we had that there. And everything is going in our area 0. So now let's run this and let's watch as Claude uses the new tools that we've given it to configure our network. So like I said, again, last video, we gave Claude the ability to run show commands. I've gone ahead and given Claude the ability now to run send config commands. And don't worry, I'm not going to do the coding right now in this video, but I will go over a little of a review at the end of this. And then of course, all the code will be uploaded to my GitHub. So here we go. You'll be able to have it there. So let's go ahead and continue. Here we go. We've got Claude sending configs to both R1 and R2. It tells us he has configured it on both routers, and now he's moving into the verification state. So he's now gone from using send config commands to running back to his show commands to verify. Okay, and as it goes along, it's telling us the neighbors are forming. They're currently in a two-way state. So it's not going to just drop and tell you, say, hey, I've done it. Now go check on your own. No, the connection is going to stay open, and Claude is going to keep using MCP, running those show commands until we get the intended state. Okay. And as we see here, the interface is in waiting. The DR election is still in progress. Even tells you how many seconds are remaining. So it's going to continue to wait. And as we see here, we've now transitioned to X start state. The adjacency is forming with R2 as the DR. So it's going to check again. And finally, here we go. This is what we were waiting for. OSPF is now fully configured and operational. Okay. R1 and its OSPF neighbor, of gig 2. So it's neighbor. So we have R1 here with the neighbor ID. That's the management interface that we have. We could change that obviously if you wanted to. We could have told it to create a loopback and use the loopback as the neighbor ID. And the loopback would have taken over as the native ID if we wanted to. But it did it automatically because we didn't specify that. But as you can see here at the end, we have a full adjacency with our OSPF, and we did not have to log in one time. Now we can log in to our devices. Let's just pull our device up real quick. Okay, and we'll just do this is R1. So we'll just say, I'm not gonna do the OSPF. I'll just say show IP protocol. And as you see, there we go. We have our OSPF is now configured. It is up. It tells us that we're routing for these networks. Okay. It tells us our router ID, and all that good stuff. So OSPF is good to go. It has been configured. Okay. So next, we need to verify or confirm that the change has been made. So, this is kind of one of the most important parts, is just to verify that what you've done has actually worked. So the way I'm going to do that, and even though we have Claude tell us right here that it's up and operational, I want to verify. Of course, obviously, if I hadn't logged into the router myself. So I'm going to say verify OSPF neighbors are up on R1. Okay, and again, we're going to run those show commands to check. It's getting all of this data here. And now it tells you OSPF neighbor is up and that we have a full adjacency with R2. All right, so let me show you, this right here is just telling us what we know, that it's working and it's up. Let me actually show you why the structured data matters, and what, kind of what happens when I ask for interface details from Claude, okay? So I'm gonna say learn the interface feature on R1 and tell me which interfaces are up. Now, we're talking about now another feature. This is the learn feature. So before the first video, we gave our MCP server the tool to run show commands. In this video, we've given it the ability to send config commands, as well as use the learn feature. Now, again, this is powerful because now Claude is going to be able to learn using MCP and through pyATS. It's going to be able to learn all the details about our interface that we asked, because we asked, to learn the feature on the interface feature on R1 and to tell me which interfaces are up. So it did that on R1. It says the interfaces that are up are gigabit 1 and gigabit 3, and we have gigabit 2 and 4 down. Now, if we look back at our learn feature, here's everything that we learned. Of course, let me actually expand this so you can see it. Okay, so all of this right here is our structured data that pyATS was able to give. We're learning things such as the interface description, the type of interfaces, the operational status, the MAC address or the physical address, the port speed, the MTU, whether or not it's able, the bandwidth, flow. All of these things are data points that we could not get using just the raw CLI. So you could then take this data and create powerful documents, create powerful analytics that you could then use to have a better insight into your network. So I think that's pretty cool that you're just able to ask and get all this information on your network devices without having to log into them. That's pretty cool, right? So that's basically the walkthrough, guys. What we've done is we've taken two routers that had no configs on them. We have implemented MCP. We've implemented a pyATS, our pyATS library that allows us to implement our TDD framework so that we can now capture baselines and verify the config changes that we make. And now, let's just talk about the three tools that we've put into given access to the server here. Like I said, the first one is our learn feature, and this basically is going to allow us to use pyATS and Genie to learn features from a network device and return that structured data. So this is the tool that allowed us to learn all that information and to give the AI the ability to parse that information. I say the parse. Here's the parse command that allows us to parse all that structured JSON data that pyATS was allowed us to have. Okay, so basically we're going to run a show command and return the pyATS structured format there. Now, this right here is what allows us to run this basically in a asynchronous fashion. With pyATS, it's a synchronous function, right? So we've given our server the ability to run asynchronous operations. So what we're basically going to do is we're going to wrap the pyATS synchronous nature into an async, IO 2 thread, which basically is going to allow us to run pyATS in a thread pool so that it doesn't block it doesn't block the server, and that's a key pattern to remember. We want that speed and efficiency, and we want our tests and everything to run as fast as we can. So that's why we've given it that async feature there. Okay, so we've given it, like I said, the tools to send configs, to parse commands, and to also learn information about our devices, right? So, I just wanted to come here, guys, and give you a quick, kind of recap here. Let me move this out the way. Or not a recap, but just a quick demo to show you how we're using pyATS, as well as how we're using the TDD method to be able to configure our devices if you want in a lab without having to log in them, to return structured data. Having that structured data instead of the raw CLI is, to me, the game changer, because you can push that config with natural language, and you really get a real TDD workflow, because you're able to test, configure, and verify everything with one conversation with Claude. So, if you want to try this yourself, I'll just say, the full code is going to be on my GitHub. The link's going to be in the description. Subscribe if you want more network automation content, and, check out the Techie. My website is www.thetechie.com for more hands-on labs and things that you can see of that nature, and blogs and more videos. And I'm going to keep coming to you guys. I hope you were able to gain something valuable from this from this video, and I'll see you soon in the next one. Bye-bye.